So it will be an introduction to machine learning, and it will also tell you how you can start utilizing various algorithms to attain various problem statements in the scope of machine learning and data science. Now, first of all, what is machine learning? So, as the word suggests, machine that learns, or when you make the machine learn certain problem statement and to solve it, then that whole process is called machine learning. In this session, we'll talk about a brief about machine learning, types of machine learning, the Python library which actually does machine learning, which is scikit-learn. We'll talk briefly about that, and then we'll talk about linear regression. This is one of the most vital algorithm which we will be covering pretty briefly here. Yeah. Now, if you look at a machine learning or data science problem statement, it always starts with a problem statement from the business, right? Then the first step is data integration. To solve any kind of problem, the first thing that you'll need is a data. Now, if data is there in various sources, that doesn't make any sense, right? You need to first create connectors which will get connected to data sources, come to a common platform, and then you analyze the data. So analyze data means you will cleanse the data, you will massage the data, you will do some transformations, then you will do some feature engineering. Means suppose in your data to take a decision, all the variables will not be meaningful. Out of 100 variables, there will be some 10-20 variables which will be contributing towards the decision for which you are building this model. So that falls under feature engineering. Feature engineering means the features or the variables which impacts your decision or impacts your model. So you need to kind of take those into consideration, then go further. Third step is the data modeling. Now this is the phase where you create a data model. Data model can be a supervised model, can be unsupervised model, it can be a classification model, it can be a regression model. So there is a complete horizon which will get open to you when you go down to the modeling. And there are many algorithms which are currently existing, and depending on the problem statement, you will choose your algorithm. Once your algorithm has been set, once a model has been prepared, then you take ahead that model and explain to your leadership, right? Because at the end, if you create a model and that model is not something consumable by the leadership, or that model is not helping to take any decision to the decision makers, then there is no point of it. So you take the model, either you build a visualization on top of it, or you build a report on top of it, and you take it and make your leadership understand. You explain to them, okay, what is this model output and how they can take benefit from this model. Now, machine learning as a whole is divided into three parts. First is supervised learning, second is unsupervised learning, and third is reinforcement learning. We'll be focusing on supervised and unsupervised. Now, supervised learning is that category of machine learning which gets trained on top of historical data. For example, suppose you're working in a bank and you have a historical data of the customers who have been approved the loan. It means you are having few variables from the customer's point of view, like customers age, civil score, customers income range, all these things are there, and you have one variable which is kind of letting you know whether this person can be approved for a loan or not approved. Now that becomes your target variable. Now when I want to build a machine learning model to predict or to create a kind of a model which will decide that that if a new customer data comes in, that per customer can be approved or not approved. In that case, my target variable is that one variable available in historical data which is either yes or no. Means that's that specific variable which talks about whether the person should be approved a loan or not. And all other variable apart from that target variable becomes my feature variable. Means they are contributing towards the decision. Now in this specific use case, when I go to the historical data, I have set of feature variables, I have one target variable. It does mean that I am just training a model by utilizing the historical data. That falls under supervised model because your model is being supervised by the historical data. Now coming to unsupervised model, what happens here is your data is like there is no historical data available for your target variable. For example, if I talk about, I have a set of, I'm working in a retail market. I have a set of products and I have the product price, product discounts, product type, everything is there. I want to create categories like, okay, if I want to create three categories: base, premium, economy. Now these are a new variable which I will need to create, right? In this case, it's become unsupervised learning. Why? Because this variable were not available previously. This is a new thing that I'll be creating. And this kind of learning becomes unsupervised learning. So linear regression is very well represented by one equation which is called as y cap equal to beta naught plus beta 1 x beta 1 x1 plus e. Now, if you guys have, you guys will be knowing, like, we have an equation called y equal to mx plus c. Now, this is a equation of straight line, right? Now, similarly, what happens in linear regression is it basically gives you a kind of a straight line equation which will help you in data prediction. Now, for example, just think that it is my x variable, it is my y variable. Now, my task is to draw a line or to come to a equation of straight line which will tell me that okay, when your x is here, your y should be here. Now this process of estimating the value of y with respect to the value of x is called as linear regression. Now as you all understand, if I say y equal to mx plus c and the value of x is given for at any point of time, the value of x is given here, given that m and c are constant, I can get the value of y. This is what we call as linear regression in machine learning. Now, before jumping into it, you should also know what is the value, what is m and what is c. Now, if you look at this straight line, your m is nothing but the slope here. Now, the slope value is called as your m, which is slope, and this value, so the value of y when x equal to 0 is called as your y-intercept. Now, this c is nothing but a y-intercept. So, the model will give you the output for m and c. Now, if you compare this y equal to mx plus c equation with the equation of linear regression, you'll find that this beta naught is nothing but your y-intercept, and also this is also called as intercept in a machine learning language. Now this beta 1 is nothing but your slope, which is called as coefficient in your machine learning language. Now together, when you have the value of beta naught and beta naught and beta 1, you will be having a working equation where you can feed in the value of x and a value of y can be decided. Now what is e? So what happens is, suppose you are given an equation like this. It means, suppose this is a model, and you are telling that okay, when x value is lying here, my y value should lie here. This is according to the model. But what happened in actual manner, when actual data came up, your y value is residing here. So the difference between your predicted or your estimated y and your actual y is your error. Now we'll discuss about this error point more when we talk about regression chapter. As I said, it's a brief I would like to give you here. Now this E component is a surplus, is called as a surplus or a residual. Now you understood what is beta naught, which is an intercept. Beta 1 is our slope, which is called as coefficient, and E, which is our error, which comes when you have given estimate and the exact value is having some difference from the estimate, because obviously no model is 100% accurate. So if it is 90% accurate model, the rest 10% is your surplus or error, which comes like this. Now we'll see the next part of it. This is the simple regression equation which I just talked about. So you can see there's one beta 1 x1 value here. This alpha, which is also called as beta naught, I talked about this one. Now if you look at multilinear equation, when your model involves multiple x variables, suppose you are creating a model and that model is involving x1, x2, x3. In that case, the whole equation becomes y cap equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus e naught. It means each variable will have a coefficient, and accordingly this equation will be formed. So this is called as multilinear equation. Now what is scikit-learn? Now scikit-learn is the library which holds this linear regression formula inside Python. So when we talk about the regression, like when we talk about regression chapter more elaborately, we'll tell you how do you build this model by utilizing linear regression within the Python coding and scikit-learn library. So that is something we'll talk when we go into the sessions more elaborately.